Good morning, everyone. Let me just set up my camera. Camera's good, microphone looks good. How is everyone today? Quick question before we get started. Jet was asking, are there partial marks for exam questions if you don't pass all of the auto tests? Yes, in a sense. The way to think about it is there always are. Because the way the marking works is always going to be um, based on whether your code functions correctly. So it's always going to be based on whether your code meets the specification, not what tests it pass. So we're always thinking about this from the viewpoint of did the code do what it needed to do to I guess to do what we asked in a sense. I mean, it's not always the best way to think about it in terms of like just do what the person asks you to do, but often the way we think about this when we're making code is it was there to fulfill a particular purpose, and so we design the code to fulfill a particular purpose, and if it can fulfill that particular purpose, then the code is correct. And so that's always going to be measured by going back to the original purpose itself. The auto tests and the marking tests will usually be based on matching that purpose, but they won't always be encompassing all of the possibilities around that. So I think hopefully that answers your question enough, Jet. That was the first question of the day before we launch into what we're actually talking about today. So I should get into the slides. So, quick recap of what we were doing last week. We looked at a programming concept called abstract data types. Abstract data types are our ability to create a type, in a sense. It's not quite as specific as us creating a type like a struct. When we create a struct, we look at the actual variables that go into it, and we say, okay, package these variables together, and this is our structure. And so when we define a struct, we can know without a doubt how it's going to sit in memory. We can, if we want to, have a quick look at it and say, this is how much memory this thing will actually take. This is specifically how we access parts of it. You know, we've got the specific names for the fields and everything. So it's really kind of particular how it comes together. But an abstract data type is much less particular. So we could design an abstract data type without actually saying anything about how it sits in memory or how it goes together or anything like that. We could define an abstract data type by a set of rules. So for example, like the queue that we were looking at, we could say that the queue just has a few rules, in that anything that you add to the queue will always go at the back of the queue, in a sense. So it will always be the newest object in the queue, and then anything we remove from the queue will be whatever has been in the queue the longest. So we can say, okay, those are the rules, and when we define the queue itself in the H file, we can say this is something that that should follow these rules, but we don't actually say how it necessarily should be built. And that's something we would do in the C file, and the beauty of this is we can have multiple different C files that implement the H file, but they don't necessarily have to be have to run the same. In that, if I was using a queue and one person had implemented it for me using an array and someone else had implemented it for me using a linked list, you could swap their C files in and out and I wouldn't notice the difference while I'm using it. And that's the beauty of the abstract data types, is the H file sits in between the for the examples we've been using, the simple examples, it sits between the main file and the C file, and it allows both of them to talk to each other through that interface, which is exactly specified. But it allows both of them the freedom to use it as they wish. Morning Race, morning Leon. Leon says it's gaming week. Is there actually an official gaming week? I've never known that there is an actual gaming week, unless you're talking about like week 10 of the term being gaming week. Good answer, Reese. Gaming week is every week. Okay. So that's a quick recap of abstract data types there. 1 week before exams equals official gaming week. Yeah, it's not the best time for it. I don't know if whoever's calling official gaming week worldwide, it's probably like, I don't know, EA or Ubisoft or someone like that. I don't know if they know that our UNSW schedule has terms and exams going like this. I would assume that all different universities in the world are all on different timelines anyway, so there's no way they can tell that we're really busy right now. We could, if we want to, consider Castle Defense to be a game, and so it's gaming week because what you're doing is you're implementing the back-end engine for a game, and so that makes it okay. Oh, Terry's noticed the night moves question in the lab. We will talk about that. I'm actually going to go through everything that's going to be in the exam today. So, well, not everything. I'm not going to give you the exact details, but most of them. So, today we're going to talk about the exam. We're going to talk about the format. I'm going to give you some advice for working with the exam, and we're going to start the beginning of your revision. And the beginning of your revision is us going through everything that's in the whole course, and just hitting the points for every topic that we've taught in the course. And what I'm hoping to do with that is to just sort of jog everyone's memory and say, okay, these are the things that we learnt. This is how we're going to start studying for things, because from here on out, it's really just finishing the second assignment. Obviously, I think everyone's probably still working on that. But to do well in the exam, which is actually only a week after the assignment finishes, because we're a big course. The more people are in a course, usually the earlier it ends up in the exam schedule. So I want to give everyone enough preparation for the exam so that the only thing you're being tested on is your ability to understand programming and your ability to implement programming things. What I never really want to have happen in an exam is for people to get caught out by the exam format itself. So they get caught out by the way the questions are asked, or they get caught out by the marks distribution and things like that, because like I really don't want people to have to deal with a meta when they're in an exam. So I don't know if everyone knows about the concept of a meta. So when you're playing a game, for example, there's a meta, which is like information about the game which isn't playing the game itself. It's like, okay, what are people currently doing in the game? Try to match up against what people are currently working on. And we don't want you to have to think about how to win the exam. I prefer for everyone to think about how to show what they've learnt in the course and show what programming capability they have, rather than having to say, in this exam, if I approach it in a certain way, I'll get better marks than in a different exam or anything like that. So that's why what I'm going to do is I'm going to tell you pretty much everything that I can about the exam except for the exact questions that we're going to give you. So I'll give you as much information as possible so that you go into the exam kind of already knowing what to expect, so you don't have to you don't get surprised by anything in a weird way. Yeah. Sorry. Just checking chat there. Matthew's asking, am I reading right that we can use Google in the exam? Yes, our exam is fully open book. In fact, instead of answering these questions, let me just go through the slides, because the slides are going to talk about everything that's in that. Leon's asking about secret order. Oh, actually, you know what? All of your questions have answers in these slides so far, so let me just go into it and talk about it, because I think there's lots of questions here. But what I should do is answer whatever questions survive and still need to be asked after I've gone through my little section on what's in the exam. Okay, so what's in the exam? Wait, what angle is it? All the things! I don't know if people still know this. This is like a really, really awesome webcomic. I don't know when I was reading this, like nearly 10 years ago or something. Oh yeah, and Tom's saying he will answer the questions in the chat while I'm talking about things. Okay, so obviously the exam is the final part of the course, and the exam is the thing that just sort of gives you some feedback at the end on how well you've done in the course. And it also gives us the opportunity to say, all right, for each individual in this course, how much of it do you know? So can we say that this person has learnt, 80% of what we taught in the course, which is well above how much we need someone to know to have a solid grounding in computer science and to be able to continue onwards and happily continue studying this. That's basically what the exam is going to tell us. So I mean, if we really, really wanted to, if we were in a completely different world, completely different system, we could say, here's the exam from the very beginning of the course, and then at any point in the course where you can take the exam and complete it, you can, just move on to learn something else. If we had like really, really flexible schedules at university, we could do something like that, and someone could do this course in like 4 weeks, someone else could do this course in like 15 weeks and stuff, and then it would just be like, just finish it when you're finished. I feel like that would be a wonderful way to do things, but I don't know how we would actually administer it. The other thing that I should probably say is that an exam is a necessary evil. It's not something that I think is great for your education. I don't think it's something that you're really going to learn from at all. I mean, there's one thing you can learn from an exam, is that if you take a job interview for programming, it's going to end up feeling a little bit like an exam, in that you will get thrown in a room with someone and you'll have 1 hour or something to show a certain part of your programming expertise. So they will say, here's a problem. And seriously, some of the problems look familiar from what you've seen in COMP1511. It's like, can you reverse a string? And you just like, they want to watch you go through the problem solving process for it, and they want for you to sort of produce a solution to it. So I guess there is something that you can learn from doing an exam that you might get later, but to be honest, it's a bit arbitrary. Exams just create a whole lot of pressure for students, but there isn't actually a way that we can give you all good individual scores by the end. Because if I just marked everyone based on the assignments, then I'm not just marking you on your individual capability, I'm marking you on your programming ability, the programming ability of everyone you communicate with, whether you know good ways to ask for help on things, and whether you know how to use the internet well to get answers to solutions, and to learn about techniques and to go back over material and stuff like that, which is worth marking people on because those are valuable skills. But the exam is like a point where I want to take a snapshot in time of each individual in this course and say, okay, at this time, after the course is finished, I can say this person knows this much. In a perfect world, I would love to just sit down with every single student. I mean, this is like really valuable stuff anyway, if I could. Sit down with each and every one of you for about an hour. I don't know, probably longer than an hour for everyone. But just sit down and talk to you for about 2 hours, because I know that if I spend about 2 hours with each person and just talk to you, let you use a computer and a whiteboard and stuff like that, by the end of that, I would be able to give you a mark, and it would be a fair mark, and it would be really good, because, you know, any silly mistakes you make, we'd just talk about it on the spot, and we'd sort it all out. And I'd be able to say, okay, this person should get, 80, this person should get 55, and it would be fine, because I could just see what everyone was capable of doing. The only downside to that is you'd all get your final marks sometime around, I don't know, I'm thinking 2023 or something like that. Like, there's just no way that I could actually assess everyone and write it all up in a timely manner so that you could actually continue on with your degrees, because I think we've got 750 people or so I think just the amount of time that would take would be measured in years, months if I was lucky, but most likely years, how long it would take to assess everyone. So unfortunately, we have to do something like an exam where we say, all right, everyone's going to do the same questions, and just bam, do them all, get them all out of the way, and then we'll be able to record, and we'll be able to use a lot of automated stuff to be able to process how many people we've got doing this at once, and so we can get you all the feedback of what you're doing so you can move on. Okay, so some of the administrative details of what's going on in the exam. I'll just shrink my face so that we can see that. So we're starting at 9 a.m. Australian Eastern Standard Time for anyone who is not currently in Australia. And obviously, I think everyone knows this now, we are not going to put you all in a room together. We are not going to put you all in our labs together. We have a current ongoing pandemic. There is no safe way to sort of lock you in a space and ask you to do programming. There's no safe way to gather 700 people in the same physical location either. That would be super, super dangerous right now. So we're not doing that. You will be completing the exam on your own computer at home, which means that if anyone is having issues with internet connectivity and stuff like that, and methods for connecting to our systems, like using VLab, or other people have been using SSH. Some people have been hooking up via VS Code as well. I know there's several different ways to use our infrastructure from home. Possibly one of the things you might want to do if you experience a lot of lag with stuff like that is hop on the forums and ask people about the different ways people have been doing this, to make sure that you get the best possible setup for yourself before the exam. I should point out the exam doesn't have a particular time pressure, because we've got 24 hours to do it, and it doesn't take 24 hours. But let me go through the points one at a time, actually. So everything is done using terminal commands. So everything we've been doing before, using terminal commands like autotest and give, and even just the 1511 commands, those are the things that we're going to be using for the exam. So there'll be one setup instruction that you will run that will copy the files into your directory. Anyone who's had their lab already this week has already done this. I should point out, oh, that's actually in one of my points here, your week 10 labs have a duplicate of the exam setup for you to use. So what you'll be doing in your week 10 lab is actually running the exact same software that is going to be running the exam, but obviously not the same questions, because we're not going to give you exactly the same questions, although the questions are really similar. So the questions are really similar format and really similar setup to what's going to be in the exam. So what you'll do to start the exam is you run a command, and it will copy a series of files into your directory on CSE, and then you'll be able to go through those files and and fill out the answers as you need. There will be some, I think, where you have to create the file yourself, but it'll be really specific. It'll be like, it has to be this file name, and then you submit it. Auto tests and your submission will be done also with terminal commands. These ones will be quite familiar to you because they should be in a really similar format to what we've had in the labs. So it'll be like 1511 auto test and give and stuff like that. Hello. Someone's come to say hello. So there shouldn't really be anything in the environment that is super different to what you're used to in doing labs and weekly tests. So we've actually really set up the labs and weekly tests so that they're already kind of testing you on how well you can work with the content that we have, and so the exam goes in pretty much the same format. We have previously done this exam. It's not exactly the same exam, but really, really similar format. In 3 hours in person. So in 3 hours in person with no internet, no access to lecture materials or anything like that. So the exam is designed for, I guess, for most students to run out of steam somewhere around 3 to 5 hours. It's not super exact how that's going to be, and that would have been 3 hours of like laser eye focus. You do this and you do nothing else. Like, you don't have your family in the next room. You don't have your smartphone nearby to throw notifications at you and stuff like that. So if we had complete exact focus on the exam, I'd expect everyone to be able to pretty much earn all the marks they could earn in about 3 hours. So it may be a 24-hour exam, but it's not designed for you to take 24 hours. In fact, if you spend 24 hours on it, most likely, I would say the last sort of 12 hours at least of that would be completely wasted, because you would have exhausted everything you know about the course way before that. I mean, 12 hours is quite a long time to spend on this, and most people won't need it. And even if you do spend those 12 hours, the amount of marks you're going to get out of it will be negligible. It won't really make any difference. So with submission, you can of course submit as many times as you want, same way as an assignment. So you can see how a lot of our systems are just working exactly the same way as everything else you've seen in the course. There won't be any weird surprises in the exam. Also, yeah, your lab will show you what it's like. The one thing that we will be doing, because we won't have our forums open and running during the exam, so we won't have the capability for people to communicate in a public way to accidentally tell other people about the code and stuff like that. So everything's going to be going back and forth via your UNSW email. So one thing I was saying that you may want to check to make sure that you've got some way of connecting to our systems to do auto testing and stuff like that. The other thing is you will want to make sure that your UNSW email is working. So check that. Make sure that you can receive email at your UNSW email. So that should be Z student number at student.unsw.edu.au. It's good to check. Just send yourself an email from another address. Make sure you're receiving something, because we are going to be sending you the link to how to access the exam via your email. I think that's my next slide, actually. Yeah. Okay. So, did I have it on this slide? No, I had it on another slide. We'll also be sending out a test email. We'll send out a notice, actually. Makes no difference if we send out a notice, because the notices that we've been sending out from the course also have been going to your UNSW email. So that's a good test as well. If you've been receiving all of the weekly notices that we've been sending out about COMP1511, then your UNSW email is working. All right, let's talk about how the actual exam's going to run. So this is an open book. Like if we want to use the technical terms for how this exam works, it is a take-home open book exam. So a take-home exam means that they've got questions that you do at home. Open book means that if we had a textbook, it would be open. You could read anything you want from it to do this. So what we can say is that, you know, my YouTube channel or the uploaded lectures on Echo 360, they're all open. You can use them if you want. You can use most things on the internet. So I should actually just jump to this point and talk about it, that we can use whatever's on the internet at 9 a.m. when the exam starts. If anyone puts anything on the internet after the exam starts, that's technically off limits. So the only things you got to watch out for is you don't get to go on Stack Overflow and upload the entire exam and say, hey, can someone help me with these questions? Stack Overflow is really, really like, they'll know when you're doing that as well. They're just like, oh, this is another student trying to get us to do their work for them. So just don't do that. Right. The other thing is, this is still an exam, so what we're doing is we're trying to figure out how well you're going individually. And so for this to be individual, we're going to ask everyone to not use any of your discussion groups or online help or questions. If you've got private tutoring or anything like that, you're not allowed to talk to your tutor during the exam. So this has got to be what you know. And I'm okay with people looking up like static advice, like stuff that just sort of sits there. So my lecture slides, my videos and all that kind of stuff is fine. But if you go asking for really specific information about the questions themselves, that's where it doesn't work. So that's where you end up not getting an accurate idea of how you've done in it. So you can't share the code at all, which means don't show the code to each other and don't show the code to anyone outside the course. If the code turns up elsewhere afterwards, we'll go looking for you, but you know, we'll find you. I should put a Liam Neeson voice on like that. I have a particular set of skills. Anyway, so the only people that you can discuss the actual code itself with is the COMP1511 subject staff, and we will be available. So during the 24 hours that the exam is running, especially at the beginning when most people will be starting and looking at the code for the first time, we'll have a set of tutors who are available who will be ready to answer all of your questions and clarify what's going on. They should be able to give you all the information you need to be able to use the exam correctly. So the way to do that is we have this email address, 1511.exam. So it's like our normal address, but this one goes to more people than just Tom and myself. So this will be whoever's monitoring the exam at the time. We've already got a roster of people on. And yes, there will be people answering this email for nearly the entire 24 hours. I think there is a gap in our schedule somewhere around 3 to 4 a.m. I think Sydney time, where it's like it's pretty hard for us to necessarily have someone staying up at that hour and answering questions. But for I think nearly any other time in the exam, you'll get a response on this email address very quickly. So that's how we'll be running the support, and it's the same way as if we had a sit-down exam where you're all in a room together on our computer labs doing the exam. That's how we would have run it if it was in person. We would have an invigilator in every room, so there would be a tutor in every room with you, and you could just put up your hand and say, I need clarification on this question. Does this mean what I think it means? And then they'll be able to tell you it means X or Y, or even like put a message out to everyone saying, okay, we found an error in the exam. It's actually this. So we might. Tom's saying that the gap is 4 to 6 a.m. that we probably won't be monitoring things. I should also go back to the idea that we're asking you politely here not to share things with each other, not to discuss things with each other. And I do understand that not everyone takes the polite request to not cheat with each other. I'm just going to point out now that we've already caught 20 people cheating in the first assignment. We haven't actually notified you of this yet. We will be doing this fairly soon, but you already know who you are. I don't know. I mean, honestly, it's not always the same people who actually go to lectures who cheat, because usually if you've gone to lectures, you don't need to as much. But those people who have worked with other people or got other people to do their assignment for them will be in contact with you. I should say that if you do the same thing in the exam, then there's pretty much zero chance that you can pass the course. So please be careful with this. It doesn't help you at all. So it might look like you can get higher marks by using the same code that someone else used, but we weren't born yesterday. We're actually very good at analyzing code, and we can tell if a couple of different people have used the same basis for their code, even if they haven't used exactly the same code. You can't just go in and change all the variable names and then have us go, oh, that's not the same code, we can't tell the difference, you know? So if that has been how you've gone so far, please just be careful of this, because it doesn't help you in any way. The worst thing that can happen, I think, if you've been using other people's code to get through this subject, I think worst case is like we'll just pick you up and say, look, we have to fail you for the subject, you have to do it again. Best case, which is still pretty bad, is that you pass the subject without knowing everything. And so if you pass the subject without knowing everything, all you do is like you don't know how to swim, and then you just go into the deep end, right? So if you do end up cheating in the exam and you pass the course, what you end up with is the courses that follow this don't get easier. Like, there's no point in courses getting easier. What they do is they leverage what you already know from what you've learned in COMP1511 to be able to continue learning. So if you haven't learnt everything in COMP1511, you're actually much better off doing it again than you are pretending that you knew what you were doing. Okay, back to the actual exam itself. Yeah, this email address will be the contact, will be the way to reach us. Okay, some technical details. We've covered some of these already. Is that we will send you an email at your UNSW email address. This will go out 2 or 3 days before the exam itself. So look for this midweek. We will also send out a course notice at the same time. So you should see the course notice appear on the course website. You should see the course notice appear in your email inbox, and you should see an email about the exam in your email inbox. So you'll be looking for all three of those things. You'll know there's a problem if you see the course notice go up on the web page, but you don't see any emails. So if you've got that issue, then you definitely want to get in contact with us, and then we can make sure that at least do some troubleshooting maybe yourself to make sure your UNSW email address is working. If you want to be prepared, you can check that now. You can just use another email address like any other email account you have to email your UNSW email and make sure it's receiving. That's always a good thing to do. The email that we send you a few days in advance will contain a link to the website where you get the questions for the exam. Obviously, that website will not be running when you first receive the link. That website will start serving information at exactly 9 a.m. on the day of the exam. So 9 a.m., I should say, is in the Sydney time zone, which, if I remember correctly, is the Australian Eastern Standard Time. So you will, at that particular time when we flick the switch, that website will start working. So if you want to, sometime around 8:55 that morning, you can just keep clicking refresh until the website runs. You don't have to do that, by the way. Like, even if you like, you also don't even have to start at 9 a.m. if you don't want to. I mean, I know a lot of people are going to, because, you just want to see it when it first appears. But as I said, 24-hour window, and we expect most people to spend somewhere between 3 to 5 hours on this. So if you plan out your day, you don't have to start dead on 9 a.m. if you don't want to. I mean, personally, I would probably read the questions at 9 a.m. and then go off and do something else, like go for a walk or something and let my brain spin the questions over and then come back and do them later. But up to you. You do what you want. I'm not going to tell you exactly how you should run this exam, because you might have other time pressures. So UNSW in general allows exams to be scheduled 2 on the same day. And because we've said to UNSW that our exam is expected to take up to 5 hours, they've said, okay, so that means we can schedule your 24-hour window and someone else's 24-hour window at the same time. Because in a normal day, if we'd sat you down for 3 hours for the exam, and then you have 1 hour for lunch, and then someone else sits you down for 3 hours for another exam, that would be a standard kind of procedure for UNSW. I think there are still a lot of people who have potential timetable clashes with other exams. Anyone who also has special consideration for what they need for the exam. Usually the 24-hour window allows you so much time to do it that it's okay. But if anyone's got any issues with it, you can always just get in touch with us, and we can make sure that whatever provisions that you need are still accounted for under this setup. Because the usual exam provisions that we provide are based on a very, very short time for the exam, like a 3-hour exam, and then people get extra time because in a 3-hour exam it's a lot more time pressure than a 24-hour exam. This week, as I've said before, the lab is a good thing to do this week, because in the lab you actually have access to the practice exam. So the commands in the practice exam are very, very similar to the commands that will be used in the main exam. So you can just make sure that all of this stuff works, and you have an environment that works in it this week, so that next Friday, it is next Friday, isn't it? Yeah, it is. Yeah. So that next Friday, when you're looking at the actual exam, you've kind of already run all the commands, and you know that they're definitely going to work. I'm just sorry, I just went back through chat and Tom's like, please don't sit there refreshing madly. Yeah. Yeah, 10 days. It's exactly 10 days from now. We'll be 40 minutes into it 10 days from now. Terry, the exam is on the 14th. Where did I say it? Here. Friday, 14th of August. 24 hours that starts at 9 a.m. Friday, 14th of August. Okay. So, I hope that covers a lot of just the administrative details for how the exam's going to work. If you want any more information on exactly how the exam's going to work, I think the forum's a good place to ask at the moment, because I think if you are thinking that you're unsure about how the exam's going to run, asking on the forum's good, because chances are it's something that I've said in this last half hour that's made you feel unsure about it. So other people are also going to want those answers. So ask in the forums if you're wondering about any other details of the exam. That way we can release more details. We can tell everyone about it when we answer your question. On to the assumption now that you're able to access the exam environment and you want to start doing the exam. Let's talk about exactly what is in the exam. So the exam will consist of these questions here. So UG is saying it's kind of like it's due on Sunday. Is it Sunday? I think it starts on Friday, which means it's due on Saturday. It's like a really, really short assignment. It's like a one-day assignment that starts on Friday and is due on Saturday. I wouldn't necessarily treat it like an assignment, but you kind of could. You kind of could, because it's like these 7 practical questions that are in stages. You don't need the earlier stages to be able to complete the later stages, though. So it has much less narrative than than an assignment. Oh, you're just saying you mean the practice exam? Yeah. The practice exam is runs for longer than the normal exam because it runs for the whole week, just like the lab. So you've got until the end of the week to submit in the same way that you would have for a lab, which means you can keep going back to the practice exam environment just to get some familiarity with it if you want to. Okay, the exam format itself. 10 short answer theory questions. These are quick fire questions. I would say that in terms of the difference between the questions, these short questions and the practical questions, the practical questions are really, really similar to lab and weekly test questions. If you have been listening very carefully and probably re-watching lectures and doing all of your labs and stuff like that, so if you think you've got a really, really good grasp of how the course runs, then these 10 theory questions, you could answer all 10 of them in the time it would take to answer probably one of the practical questions. Because a lot of them are you know it or you don't. And if you don't know it, you can look it up and say, do I understand this? So these things are just going to be testing your general understanding. So if we think you need a wide understanding of a lot of different things to be able to use them correctly, then we'll ask questions about that. So this is kind of like, if there were 10 topics in the course, each one of these would cover a different one of those. There's more than 10 topics in the course, so there's no easy way to cover everything. But we've asked a few questions just to be able to see how you're going. The practical questions, being similar to the lab and test questions, mean they're in an escalating difficulty. I'll talk about that in a second. Let me just put my face back. I shrunk it before because I was talking about other things. Okay. General advice for surviving an exam. This is advice I often give people when we're talking about full-on high-pressure 2 to 3 hour exams. But I've modified this to be something for a 24-hour exam. So, simplest one, which is really funny, is drink water. And people forget to do this a lot of the time. Lead by example. Being dehydrated lowers your brain functions. Also, being distracted lowers your brain function to a certain extent. This is not something that you can definitely control. I don't know how many people have siblings in the house who are going to be really loud and annoying, and you won't be able to necessarily concentrate. However many of you have families who are potentially going to interrupt you while you're doing this. You will have to find a way to get the best amount of focus as you can while you're doing it. The other thing is, drinking and eating. I know that the exam might feel like it's entirely theoretical, it's entirely in an abstract world, but it is not. We are physical beings, and you need blood sugar to make your brain work. So your brain runs on blood sugar. And that's not to say you just eat 1,000 gummy bears and do the exam. I don't think that's how that works. I haven't tried. Maybe it works, but I don't. I'm not sure. But yeah, eat proper meals. Um, don't throw out your physical rhythm just because you're in an exam. And actually, it can work really, really well to do your normal routine of when you eat meals and stuff, and actually step away from the exam. And so if you eat with a family, or you eat with whoever you live with, usually in your meals, try to still do that, because even sometimes just having a conversation with people who know nothing about your exam about something that's completely separate from the exam is a really nice refresher. It resets your brain and gets you thinking again. The other thing that resets your brain is sleep. This is not a 24-hour exam. I have to say this. I've already said this several times, but I'm going to say it again. It is not a 24-hour exam. It's a 3 to 5 hour exam that has a 24-hour window to make sure that everyone in different time zones has some good time in the day that they can actually do the exam. So get normal amounts of rest, um, and and I've seen people do this. This is the reason why big companies like Google and stuff have nap pods, is that when a problem's too hard to solve, having a nap is actually potentially really, really good. Your subconscious brain might still be turning over um, your thought process about a problem when you're napping, and then you get up half an hour or an hour later, and then you might actually have a solution to difficult problems. There's a limit to how many times you can do that in a 24-hour period. Take like a 1 or 2 hour nap or something like that, but it is actually potentially possible. So you could spend some waking hours doing what you can in the first few questions until you get up to one that's too hard, and then you could say, okay, I'm gonna have a nap now and come back later. So it totally works. And the other thing is taking breaks. We can't usually focus that well for more than about an hour at a time. So it's good to take breaks in between. Hence why the lecture always has a break in the middle. For myself, I don't like talking for 2 hours straight. It hurts my mouth. Hurts my throat more than my mouth. But also it hurts your brains to have to absorb data continuously for 2 hours, and it will hurt your brains also to be working continuously for more than, say, an hour at a time. Although, to be honest, I'm also talking to people who can probably... I don't know if everyone plays computer games. I just assume that everyone plays computer games. Play computer games for like 3 hour stretches at a time. But I guarantee you're probably going to be worse in the third hour than you were in the first hour. But if you take breaks in between, you might be okay. Yeah, so I think I've noticed here I'm really hammering it in the slides as well. You could work for 3 hours on this exam and it would be enough. In fact, if you want to, you remember the weekly tests. Well, you should remember the weekly tests because we're still doing them. They're not all finished yet. The way we set up the weekly tests, and the way we said this is the good way to do it, is do the weekly test for 1 hour. Like, seriously, lock yourself in and do the weekly test for 1 hour, and then at the end of that hour, you know how you're going with the course. If you want to, this is like super challenge hard mode for the exam. If you want to, close all your browser windows except for the questions, and only do the exam with what you have in your head. No lecture slides, no internet, nothing. The only thing you're allowed to work with is a single piece of paper and a pen or a pencil. You can have more than one piece of paper, but that's it. Piece of paper, pen and pencil in your computer. You've got auto tests as well. And just do it for exactly 3 hours. And see where you go at the end. This is unnecessary pressure, by the way. So this is total challenge mode. You don't have to do this. But you could if you wanted to. Do it for exactly 3 hours and see where you're up to. At the end of that, you can say, okay, if this had been a sit-down exam, this is where I'd be. I'm reasonably happy with how the course went. Now I'm going to look up some lecture material, relearn a few things, and then get a few more marks in what I'm doing. So if you want to, you can do it that way. You don't have to, by the way. No one has to do that. But what I can say is that if you do it like that versus you spread it out and you do like 15 hours of work on it over 24 hours or something like that, your marks aren't actually going to be that different. Like, I know this because I've marked the course in 2 different ways. We've done this take-home exam before, and we've done it in a sit-down exam for 3 hours, and there wasn't a significant difference in the marks people get. So what we're getting is a situation where you don't have to spend 24 hours on the exam. And I have to keep saying it because I know people aren't going to listen to me. People are going to try to work for... Because I've seen the memes that everyone says that when they get a 24-hour exam and the lecturer says it doesn't actually take 24 hours, people end up spending 24 hours on it. And I just want to point out that if you do that, you are going to spend a lot of time on fiddling with bits of the exam that don't even get you more marks. So just bear that in mind. You're allowed to stop. You know, you're allowed to hit like 4 or 5 hours worth of work and just be like, all right, that's enough, you know. But that's also a very difficult skill to learn about, how to stop, you know. Okay. Oops. Get out of the way of the text again. In terms of preparation in advance, there's a lot of things that you can do. So you can go through, and this is what the lectures this week are about, doing a recap and stuff. You can go through and say, okay, these are the exact topics that I need to know about. How do I actually learn about each of those? How do I prepare in advance? Because you can, if you want to. There's a few days, not many, but there's a few days in between the end of assignment 2 and the exam itself. It could be enough time for you to look at every single topic of the course at least once. And if nothing else, you write down the key points of each of those, and you can keep that list of key points with you when you're doing the exam and go, okay, these are the things I want to remember. Also, it's an open book exam, so you could prepare a set of notes for yourself which tell you where to look up the things you need to know about each thing. There's just even something simple as like, this lecture that Marc gave at this point is where he did a code demo on this particular thing, you know, and that might help you. I've noticed that someone has been doing that. I don't know who it is, but someone has been tagging my videos with different time markings for certain topics and stuff, and it's like, okay, cool, you know, do whatever you want. It was really weird because at some point they tagged just random times and they stopped saying what the topic was, and I was like, I don't know what this person's doing anymore, but it appears to be helping them, so I'm just going to let them leave comments on my videos with particular timestamps in them. They don't appear to be doing any harm, so I'll just let them do it. The other thing is to leverage human thinking in different ways, is that we can think of a lot of things visually if we need to. So if we need to, we can say, especially with something like a linked list or something, we can say, if I draw this, it's going to be easier for me to understand what I'm doing with it. Like, I'm going to know what, where I want to move my pointers because I've drawn what my linked list looks like. Tom, you've tagged me. You said, I think it's Google. Oh, right. Okay. So it's actually, like, I think what Tom's meaning there is that it can potentially be harder to do an open book exam because there's too much information available to you. And so I'm gonna talk about this bit here. I'd say chill out. This isn't a big deal, but no one will believe me. Because I say this every term. Every time I teach this course, I'm just like, look, the exam is just one little thing that you have to do. It's not the most important thing you have to do. It's definitely not the most difficult thing you'll do in programming. And it is interesting. And I hope that everyone will reach this point. And it really depends on yourself and where you end up and what you end up choosing to do. It's not something you have to do. But most everyone, I hope, will get to a point where this exam, when they look back over it in a few years' time, they'll be like, give me 15 minutes and I'll just ace this whole thing, you know? And so I hope that that's where everyone gets to, where in the overall scheme of your journey through learning, this exam is just one little bump along the way, and it won't be something that, you know, causes too much pain in your memory, I hope. But we'll see how we go. Okay, so more details. We're going to break down bits of the exam itself and talk about what they are, how many marks they're worth, and things like that. We might also go on a break somewhere in the middle of this. I have a break set up for after I finish talking about the exam, but I think like we're going to want to talk about the exam after the break as well. So, short answer questions, they're really quick. I should have said before I started this. Yeah, Taylor says it's a big deal because it's happening to you right now. Yeah. And I know. And so I also don't want to say that it's not a big deal, so don't take it seriously. Like, take it seriously because you care about it, right? Always put the effort into something that is relative to how much you care about what you're doing with it. And I hope that people care about their programming now. I hope that they've seen enough of it. You've seen enough of it that you want to do something interesting with it. And if you want to, always when people want to do something interesting with something, then that usually means they're going to put some effort into learning about it. But up to you. I'm sure that there are some people in the course who are saying, all right, the mark of 50 is very important, and I want to just get above that. So I just need to do what I can in this exam to get myself over that line, and it'll be fine. Because there's always people who are counting the marks and going, oh, can I pass? Can I pass? And I know that's really stressful. So I apologize, because it is stressful and it's really difficult to do that. And so if you're in that situation, now's a good time. I'm just about to talk about how to count the marks and how to get the maximum marks. Okay, so the quick questions are 1 mark per question. And when I say 1 mark here, there's exactly 100 marks in the exam. So I don't have this random kind of weird number of marks available for things. It's just every mark is a % in the exam. So if you're trying to get an exact number of marks for the exam, you can calculate it if you want to. I wouldn't game the system like that. I would be a bit more careful and try to do more than you need, because if you're looking to get exactly 50 in the course and you miss by like 1 mark below, then it's really, really sad, right? So don't calculate to get only exactly 50. Always try to push a little bit higher. Okay, the quick questions are worth 1 mark per question, and they will be pretty simple, like multiple choice or short answer. And some of these short answers are literally like, 5 letters or something like that. So it might be something really simple, like what will this code do? And so we're going to test you on quite a wide spectrum of what you can know or learn about code. So I did get a question in a previous exam when I asked a question, and the student was like, "This is ludicrous. Is this seriously your question?" Because I said the question was, "What will this code do?" And you can literally highlight it, copy it, paste it, put it in gedit, save it as a file, compile it, and run it, and then type that in as the answer. And they said, "Is this all you're asking?" It's like, yeah. I'm happy for 1% of my exam to be, can you type code into an editor, compile it, and run it? Because I consider 1% of what we've learned to actually be able to use a command line interface, use a compiler, and run a program, even if you haven't written anything in the program. So there are some marks like that, because that's actually part of what we've taught you that you literally did not know before we started the course. So I'm happy to give marks for that kind of thing, right? I'm not saying that every one of the quick questions will be that easy, but they're testing a wide range of what you know in the course. So there will be some questions like that, like literally, what does this code do? But then there are some questions like, okay, smart ass, you can type in code. Now, how does this particular piece of code work? Or how does this concept work? Like, trying to think of something interesting. Here's a concept of a linked list. If I was to try to access it like this, what would happen? You know, and then it's a matter of like, yeah, sure, if you want to do this code to see how this thing works, then it's going to take you like an hour. But if you understand the concept, the theoretical idea of it, it only takes you like 2 minutes to answer that question. So that's that kind of thing where we might just say, all right, so we've got this idea of a stack. How does a stack work? And you'd be like, oh, not sure. All right, so go look up the lecture. It's like, okay, that's how a stack works. Right, this is what we're trying to understand. Yeah. So there are some examples in the Week 10 lab about this, and I think at least one of the examples in the Week 10 lab is one of those simple ones where it's like, all right, tell us what this code does. And if you want to, you can just look at it and you say, all right, if I read this line by line, I know what this does. Or if you want to, you can say, look, I need to verify this. So you can copy the code in, run it, see if it runs, see how it runs, and then get an idea about it from there. Either way, you're going to show that you understand it. Oh, Tom's letting people know about what the Marc's breakdown is. Oh, we're going to go through that here anyway. Okay, so you'll see some examples in the Week 10 lab that will tell you about these things. The details of how we're going to do this is we will give you a text file when you download the package of files, which says exam. That doesn't actually stand for exam mark sheet. That stands for exam multiple choice. It's not exactly multiple choice, but it's a text file that we have given you in a specific format. So it'll have a section for each of the questions in it, and each of the questions will have this triple curly brackets somewhere in the text, and then you will fill out your answers inside the triple curly brackets. So either there'll be a string of text in the curly brackets there, or you just put in the letters A, B, C, or D, or something like that if it's actually a multiple choice. This text file will then be submitted just like a code file, and those answers will go in to our system, and our system will just check the text that you wrote inside the curly brackets and see whether it matches the answers that we've intended for the questions. As far as I can remember, Tom can confirm with me that there's actually an auto test for this file itself, so that when you submit it, it will actually tell you whether the answers you've typed in are of the correct format. They obviously won't tell you whether the answers were correct or not, but if a question is a multiple choice where you have an A, B, C, or D, and you type in the word yes, our checks will actually say, hey, this question you have answered something that doesn't fit the expected answer format. Maybe you want to go back and check that. So if you accidentally put the answer for question 9 in question 8, like you get mixed up by just because you're not looking at things super clearly while you're answering the questions, you're thinking about the problem, not about the text file. It will actually tell you that that it looks like you've answered the wrong question there, and then you can go back and change your answers, right? So there's actually a bit of a backup there. There's that sort of auto test. Yeah, I think Tom's saying the same thing there. Yeah. So if you want to know how this works and how you answer it, there's one of these in the lab this week. So you can actually go in and say, okay, here's the practice multiple choice thing, and it has exactly the same kind of text format for here are the triple curly brackets, here are the things you can fill in. But in this one, you can actually submit it and test it, and it will say, okay, you got these right or wrong. There's no particular lab marks assigned to this week. It's just a practice thing so you know how it works. So my tips for the short answer questions are, these are actually general exam tips. What I always like to do when I'm in a situation where a lot of technical stuff gets thrown at me is I don't try to answer anything before I've read it all. I'll get a bit more context, I'll get some understanding of everything after reading it. We know that people do better in things if they've read it all before they start working on any of it. So that's why most pen and paper exams that you might do, I don't know if there's really any in-person exams happening at the moment, but most of those exams will force you to do reading before you're allowed to write anything, because they know that if people jump in and start writing, they may miss something important. So when you're running the exam yourself in your own home, you kind of need the discipline to do that. So read things quickly before you start answering. And if you want to, you could have a piece of paper that has numbers 1 through to 10 on it, and then you could actually write next to them, this one's easy, this one's hard, I need to look up this one, and that kind of thing. And then you can just plan out your next half hour or so of how you're going to do these quick questions. You go, okay, question 1 was easy. I look at it and I go, yes, that is pretty easy. Type it in. Question 5, I wrote down for myself, you need to look this up. Okay, so question 5 was a looping through arrays question. So let's go to the lecture notes on looping through arrays and say, okay, I needed more detail on this. This looks like this. Okay, now I can answer this, you know? So if you make a plan for yourself and follow the plan, it's going to be much easier than if you just sort of throw yourself in without any thought to how you're going to approach things. So what I say is, like, you know, take some notes. You can quickly answer some of them you can't. I like to prioritize my time when I'm working on stuff like this, so I get the marks that I know I can get, and I lock them in, so that I know that, you know, all the stuff that I knew instantly, I've already got my marks. I don't leave them hanging. I go, yeah, got those marks. Anything that I think is going to be hard, or anything that I think I'm going to need some time to think about, I don't answer them yet, and I've just put a note down there for myself to go back to them later. So, you know, get the marks you can, go back afterwards, and look at things, and just sort of, it's nearly like this concept of triage, if you've heard of it. Like, this is what hospitals do, is when a whole bunch of people appear in the emergency ward, they say, okay, who can we help easily? Who needs the most help immediately? And then we help those people first. Things that we know we can deal with later. So someone comes in who's had a heart attack, they just deal with them immediately. This is different though, actually. But it's a similar idea where you say, these things are going to need us to prep and think, so we'll put them on the back burner for a moment. These things can be solved really easily, so we do them immediately and we go on. You can do this by saying, okay, get the easy marks first, and then we escalate things as we need. So if I need to check the lecture slides for something, then I'll check the lecture slides. If I need to go and watch some videos, I might just leave a note saying, look, this one's going to take me half an hour to answer because I need to go find a video, I need to watch like 20 minutes of Marc's lecture, and then come back and do it. You know, so I say, okay, let's do that one later when we've got some time, but for now, let's get all the marks that we can. Tom and Leon are discussing the enable memes box. I think that was a point where Tom said, wouldn't it be funny if we had memes in the exam? And I said, yes, that would be funny. I guess we could do that. And then the next day, I think Tom said, here's my implementation of the memes that I put in the exam. I also wanted that to be optional though, because some people want to take this very seriously. If you would like to take it very seriously and you don't want to see any memes, you can untick the meme box and you won't see any. But if you want something to kind of take your mind off the pressure, then there are jokes in the exam as well. So I think that's worth doing, because personally I think that a lot of us take a lot of life too seriously, and I know that a lot of people don't have a choice. I know that a lot of people have to take life seriously, and it's sort of forced upon you, and that's tough. And I do commiserate with you, but I think that there's always a way that we can try to look at the world where it's like, yeah, this is tough. Yes, I've got hard things to do. Yes, I've got deadlines and things, but that doesn't mean that I'm going to allow this to suppress who I am as a human being. And I don't think, I mean, I know it's like kind of impossible in the world we live in, but I don't think that we should be, well, I don't think we should have our personalities suppressed like that. So, yeah. Terry's asking if Tom is making the final exam. Tom's making a lot of the memes for the final exam and the infrastructure around the final exam. Um, but the questions are a combination of things that I've written before, things that other people have written, and stuff like that. So I'm not just lumping the whole exam on Tom like that. Yeah. Night Moves predates both Tom and myself in this course, Terry. So I'm pretty sure that was an Andrew Taylor special. So you will potentially meet Andrew Taylor in what subjects, Tom? 1521, 2511. I can't remember which ones he's teaching at the moment. Um, yeah. So, did we need to say anything more about these short answer questions? Not necessarily. Okay. Practical questions. Let's talk about this after a break because it's 10 past 10 at the moment. So I'm going to skip to where's the break? Okay, so obviously we're going to end up talking a lot about the exam today because I've got a lot more slides about the exam. Andrew T is 1521 and 2041. Yeah, I think he's taking 1521 at the moment, if I remember correctly. Okay, so going on a break now, I want to talk a little bit about human memory. Because one of the funny things that we've been doing in 1511, which you may have noticed already and you may know in general from learning is a form of memory hacking. So memory hacking is the idea that there are tricks that we can use to force things into people's memory. So memorizing something involves actively recalling something. So the more times you pull things out of your memory, the more likely they are to get put into your permanent memory that never goes away. And the way this often works, like one of the ways to do this is active recall after a certain period of time. So if it leaves your short-term memory and then you're forced to bring it back up again, and you do that a couple of times, you're more likely to remember something and never forget it. So there's a reason why I will introduce a concept in a lecture, and then a full week later, you will see that concept again in the labs, and then a full week later, you will see that concept again in the weekly test. That's 2 periods of recall after enough time for it to disappear from your short-term memory. Chances are, if you've had the chance to do all of those in the right order, you end up with, it's not exactly permanent, but long-term memory of the things that we've been teaching in the course. You may notice also that a lot of the time I will recap particular topics the week after I've taught them, or 2 weeks after. So things that I think you need. I think pointers was a specific one. I recapped that one like 4 times in the course. So the things that I think people are going to need more, I push them back in again. You can also do your own active memory recall. Has anyone heard of the Mind Palace? The Mind Palace is a really fun concept of that people use. So I was watching documentaries about this, about people who do competitions for memorizing a deck of cards. So what they do is they get a deck of cards in a particular order, and they get to look through the deck of cards, and then they put it down, can't look at it, and they have to write down the order that the cards are in. And I should say that that is like an incredibly difficult thing to do, because there's 52 cards, so remembering the order of 52 things. If you think about how long it took you as a kid to remember the order of the 26 letters in the alphabet, this is significantly harder, because twice as many items does not equal twice as hard. It's actually much, much harder than that. So people do this thing with the idea of the Mind Palace, where you think about something that you kind of can't forget. So the idea of the Mind Palace, people often do as the home that they live in, especially if you've lived in the same place for a long time. So I've had this apartment here for like 10 years. So I would be really happily able to, in my mind, walk from my front door through my apartment and see certain things and know where exactly they are. and you can attach concepts to those things. So you can say, walking through my house, I remember this, so I'm going to attach an idea to that. Then I remember this, I'm going to attach an idea to that. If you link your memory to other things, that it's harder to forget, it's easier to actually remember them. So it's easier to bring these things back. And you can bring them back in specific orders, or you can walk through your mind palace in different directions and stuff like that. So there's a reason why so many of the examples that I do in this course aren't just here's how to do this thing. So it's not just here's how to work with linked lists. It is here's how we do a roster for a battle royale thing. So that basically every time you play Fortnite from now on, I don't know who plays Fortnite, I'm sure lots of people do. Every time you play that from now on and someone gets taken off the list, you're going to remember how to remove something from a linked list. Anytime the game starts and the roster gets built, you're going to go, I remember at some point I learned how to insert items into a linked list in alphabetical order, and that's how the roster is working at the moment. And so what I want is those things to happen, and so the recall to keep happening to you, whether you know it or not. Basically, I've been hacking your brains for the last 10 weeks. And if the brain hacking has been successful, then you're all going to be okay in the exam, because you're all going to remember stuff really easily, and the exam will go quickly and easily. So how well you do in this course is entirely based on how well I did the brain hacking. So if you do badly in this course, feel free to blame me if you can't remember anything. Okay, I apologize. I just talked through the whole break, which means I didn't take a break at all. And I should say here, there's another thing I say about memory is also about keeping your brain healthy as an actual physical organ, which means blood flow, get some exercise. I remember back when we could actually hang out on campus at UNSW. I remember I used to always see people near the colleges, especially studying by like walking around near the colleges with a bit of paper, and they're memorizing things, but because they're walking, they're getting their blood flowing to their brain, making it a little easier to memorize. Some people like that. Some people like to be active and moving around when they're memorizing things or remembering things. The beauty of the take-home exam is you can do that. You could do your mind palace thing, but literally just walk through your walk through your own house. You don't even have to memorize the walking through your own house. You can just literally do it. Okay, let's take a really, really quick break. So it's 18 past 10 at the moment. We'll come back at 20 past 10 and we'll continue. I have some other stuff I want to talk to you about as well. But let's just go on break for now for a couple of minutes, and then we'll come back. I see people are totally okay with their English in their HSC, and they remember it fondly and are really happy to have done it. Do they still do 3-unit English? I did 3-unit English for my HSC, but then again, I now do public speaking for a living, so you could see that like I wasn't necessarily a purely technical person. Okay, Ooh, before I go back through the slides, because I'm going to go back through and talk about the questions in the exam, because that's important. Um, I should remind everyone that because we had a public holiday on a Monday, oh, Terry, they had the HSC 400 years ago. You're right. You're right. Sorry. I am a normal human, and I did the HSC just like you did as a normal human. I have not been programmed when I was rolled off the lecturer factory floor, fully formed. Okay. Um, yes, Terry, I could be an elf, or I could be lecturer unit 01. I'm probably not lecturer unit 01, being younger than a lot of the other lecturers. I'm probably lecturer unit version 9.8 or something. Anyway, let's let's go back to actually lecturing. Lecture unit 9.8 has some bugs. It wasn't coded very well. It was coded by a 1511 student. All right. Oh, yeah, one thing that I was going to talk about, talking about revision and stuff like that. There is a revision section on the course website at the moment that instead of organizing things via the tutorial times and stuff like that, organizes things via subject, and it's got a whole bunch of questions that we didn't put in the labs. Some of them are super old exam questions as well, so you can see how they were in history. Actually, some of the solutions to them are super old as well, so take some of those with a pinch of salt, but there'll still be something useful you can learn from. There's also, we had some public holidays earlier in the year on a Monday, which means that we had some make-up times for tutorials that are happening next Monday. So that will be Monday the 11th? No, 10th. Monday the 10th. I just had to count the days of the week on my finger. Monday the 10th, we'll have some tutorial sessions, and those sessions will be specifically revision sections. So during the day, each of those tutorials and labs will be going through different parts of the course. We've got them aimed at the more difficult parts of the course, so aimed more at the second half of the course than the first half of the course. Aimed at the things that we know people tend to forget more than anything else. So if you want to, you can go to those tutorial sessions. Those tutorial sessions will not just be for whoever's scheduled in that time, they're for everyone. Tom's going to send a notice out about these because I think that Tom, I think you've already finalized the timetable for those and what's going to be taught in each one. So if you want to, and I would suggest this actually, is just hop in the Blackboard Collaborate sessions for those, even if you're studying for something else or like studying not exactly that material. Just hop in and just listen in, because there's going to be some stuff the tutors are presenting there that will be really handy. And it should mean that you can get a lot of your revision for the exam done really easily, because it's just going to be done for you by the tutors. You can just listen in and write notes and stuff like that. Yeah, so Tom says he's going to send out the timetable for it. I will do one final live stream as well in week 11, so it won't necessarily be scheduled at a lecture time, but it will probably be on the Tuesday or the Wednesday in the afternoon. I might do it Tuesday in the afternoon so that there's more time for you to use that, and then have a few days after that if people want to watch it later before the exam. But basically that will be a fully open ask me anything. You can just ask me and I will implement anything from the course and show you how it works, you know. And that will probably be the last thing that we do for the course. Okay, so let's go back, because I was going to go through the practical questions. So there are less practical questions than there are the short answer questions, but they're much more work each. So I would consider each of those to be the same as a weekly test or a lab question. And when I say the same as, I am fully acknowledging that the lab questions range from one line of code. I'm sure the early ones are like one line of code. The early weekly tests and labs are like, some of them can be solved just in one simple line, up to like 1,000. The hardest lab exercise that we have, which is the substitution solver, the substitution cipher solver that no student has ever submitted a full solution to. That one's there to just show you what cool stuff you can do in computer science. Like, not every challenge is actually there to be solved. It's there to show you what the potential is of the skills that you're learning. So they range in difficulty. We're never going to put something that hard in the exam. But we're not going to get that far off it. If anyone had a go at, say, decimal spiral, at that level, yeah, there's going to be a question that hard in the exam, and that's a matter of choice whether you do it or not. So these questions are very much in stages of difficulty. They're set up similarly to the assignment, where we say the further you can get into these, the more we expect that you can prove that you've learnt in this course. So the early ones, actually, I'm going to go through the questions themselves. I'll tell you about. Like, the early ones will have certain things in it. Later ones will have other things in it. I've got a set roughly of the criteria that I have for writing the exam questions, of what each one should be asking about. So each of these questions is an individual piece on its own, and they will be excuse me, keep drinking water. Each one will need to be written, compiled, and tested. Some of these we will give you a file to work in that may already have some setup and say, okay, you're only implementing these functions, for example. Other times we might give you a file, and that file will literally be an empty text file, and so we will say you're going to need to set this up on your own. So you need to be able to do your hash includes and your int main and all that kind of stuff. We're not specifically marking style on this because we don't have the time to get the tutors to do a full kind of assignment level marking thing on this. So you don't really need to explain it. All of these, we're going to talk about marking later. Okay, cool, that's fine. Some of these questions are hurdle questions. Hurdle questions are us saying that these are the things that you definitely need to know to pass 1511. So there is a risk inherent in the fact that some of these are hurdle questions. So the risk is that if you get a hurdle question, if you can't pass a hurdle question, then we can't pass you for the course itself. So there is a risk there that I want you to take into account. And one of the hurdle questions will be on your ability to work with arrays, and the other will be your ability to work with linked lists. There's two potential ways to pass each hurdle. So even if you have a weird issue with what you did with one of the questions, if you answer one of the other questions well enough, you'll still pass the course. Having said that, the way that most people will pass the course is questions 1 and 2. We have examples for questions 1 and 2 that I'm going to show you here in the lecture. There are also examples for questions 1 and 2 in the lab this week, so you see the level of difficulty that we're expecting people to be able to handle. As you can see from this being a hurdle that could potentially fail someone out of the course entirely, it's not set very high. So you can potentially pass the hurdles of the course by just having been in the lectures and never done anything else. Because it's actually at the level of the simple stuff that I've done in lectures. I'm going to show you about it anyway. So if you get a 50% or more, so you don't even necessarily have to pass all the auto tests if you've shown an understanding of what you're doing. You have to get 50% or more in an array question and 50% or more in a linked list question, and then you'll show you've been able to learn all the basics in the course that we know you're going to need if you're going to continue on with programming. I'll talk about the actual questions themselves. I've got an example question 1 and question 2 in the slides, and I'll talk about them. And we'll be able to show you what the kind of hurdles will look like. So some tips that I have for solving these kinds of questions, I'm going to go into detail on the questions in a second. Um, Same advice as before, read all the questions before starting. If you want to, you can do the same thing, write the numbers 1 through 7 down on a piece of paper and go, okay, 1's easy, 2's easy, for example, 3, I need to look this up. This looks like it's a question with complex looping. I need to look up how I do loops within loops and be sure of that or something. Question 5 is like, okay, that one looks like it's using, I don't know, let's say that one looks like it would be easier if I know the string library well, so let's look at the string library before doing that kind of thing. So depending on the question, you might look through and you go, okay, I've got to take some notes on these. You make a plan for yourself and then you go and execute that plan. So the other thing I would suggest is a bit of patience with each of these. There's only 7 of these questions. You don't need to rush them. So spending a few minutes not coding and thinking about them is probably going to give you a better solution. Because the first idea you have when you start hammering out the code might solve the problem, but it might solve it in a weird way that leaves out some of the cases and ideas that we might test for. Whereas if you draw it first, you think about it, you can say, oh, okay, if I think about this carefully, there's a way to implement this that's going to be the simplest way to do this. And you will save yourself a lot of time by looking for that first without just diving straight into the code. I should also say that answering each of these questions completely will get you more marks than getting halfway through all of them. If you get halfway through all of them, some of them are just going to end up with zeros, and you're not necessarily going to get that many marks. Where if you spend more time on the ones that you're close to completing, you're more likely to get full marks in each of those questions. Advice in general that you need to know about for this course, and I think people have figured this out already by now, is that counting the number of auto tests is completely meaningless. You do want to pass all of the auto tests if you can, but, and I've said this before, if my goal in programming was to pass the auto tests, then I'd write some really, really funny code. So I would say, if my input is the numbers 1, 2, 3, and 4, then my output is the number 15. And if my input was the numbers 5, 6, 7, 8, then my output is the number 20. Or something like that, right? So I could totally just do that. I could write some code which just took the auto test input and just spat out exactly the right output for the auto tests, but did not function based on the specification and based on the question and things like that. So your marks are based on whether you meet the specification, whether you can do the exactly what the question is asking of you, and the auto tests help remind you of many situations that this kind of functionality might be tested in, but they are not a guarantee in any way that they've tested everything that's possible, because that's a lot of work, nor do they give you a guarantee that you haven't missed something, right? So use them, but be suspicious of them. Yeah, and this is testing in general. We can never guarantee that the code we're writing is exactly what we need it to be. We just hope and we work on it and we try to get a decent result out of it. But go back to the spec. The spec is the thing that says this is what this thing should do, and I think that what I've implemented follows that specification. Yuji's asking if you can auto test multiple times. You definitely can, right? And you should be auto testing a lot. And if you want to, you can write your own tests for your questions. You can run your own tests for your questions. We've gone through a lot of exercises in doing this kind of thing as well. The other thing to think about is that we also have done the thing that we've been leading you towards, is the idea that in the real world there's no such thing as an auto test. You have to do these yourself. So the harder you go into the exam, the further you get into these questions, the more likely there are to be gaps in the auto testing. There'll be places where there are marks on offer that the auto tests are not telling you about. There'll be at least one question in the exam where we're specifically stating this one does not have a complete set of auto tests. And that will be in the harder section. So it probably won't be in the first 4 questions, the core questions. It'll be in the 5 through to 7, which are the kind of extension questions in a sense. Terry's saying, wait, later comp courses don't have auto tests. Of course they don't have auto tests. Later courses are expecting you to be able to test your own code, especially when we're talking about like say 3rd or 4th year courses. So if I threw you in a 3rd or 4th year course and it was like, you must create an artificial intelligence that is able to advise someone on what financial investments they must make, then there's no auto test for that. You've just got to come up with a way of building something. And in the real world, there's no auto tests either. But your experience here with using auto tests and slowly transitioning towards, how do you figure out if your code's working without the auto test? So assignment 2 very much has us saying, why don't you write some of your own tests? And you're in this sort of vague nebulous space, and people have asked us questions about that. They're saying, how do we know if the testing stuff we're writing is useful or not? And it's like, you don't until you've done it a lot, and that's why there's an entire profession for testing engineers. They don't even write any code. They write setups and ways to record the way that people use software so they can see how it breaks. So testing is a skill, and you will build that up over time. We didn't really push that too much here in COMP1511 because there's enough to teach you that I wasn't going to spend like 2-3 weeks on just how do you construct testing. But the auto tests, as like, you can think of them as a way to teach you that testing is important, and then we slowly drop them away over the course of your degree. Terry's like, imagine that AI financial question being in the exam. Yeah, that would be a bit much. But having said that, that's par for the course later on. So you're going to look, as I said, you're going to look back. If you're in a computer science degree, you're going to look back in 3 years on what I'm doing now, and you're going to say, that's pretty basic. Like, you're going to consider this fundamental knowledge that you just have by then, and you'll be doing much harder things, hopefully. Or you'll be doing something different, which is also fine. Anyway, I'm noticing that I'm feeling the final week thing, so I just want to talk to you about everything. I want to teach you everything. And the clock is ticking. I've got the clock right there, it's ticking. And I have not gotten through half the things that I said I was going to go through today. Okay, so let's look at the actual questions in the exam. So first 2 questions in the exam. Let's have a look at this carefully. 15 marks each. That means that one of these questions is worth more than all 10 of the quick questions. That's why I said the 10 questions were a quick warm-up. Whereas this is where the meat of the marks are going to be earned. There's more marks in what I consider the fundamental questions in the exam than there are marks in the extension questions. So showing off that you can do the really hard stuff is not worth as much marks as proving that you know the fundamentals, which is exactly as it should be. We're not testing you on whether you did a whole bunch of, what do they call it, informatics Olympiads, like programming competitions in high school. That's not really what I'm testing people on here, because what I want to see is whether people can understand how to program and how to use C, and that's where most of the marks are going to be. So these would be like, can you make a C program? That's a good thing. You should know how to make a C program. Can you use variables? Can you do the basics like input, output, scanf, printf? Can you do if statements and loops? Question 1 will be arrays using simple variables like ints and doubles. Question 2 will be using linked lists using simple variables like ints and doubles. The fact that it uses linked lists means you're going to need to know a little bit about structs as well. So let's look at some sample questions about what we might do. So one of them for question 1 might be something like loop through a 1D or 2D array, gather some kind of information. So looping through a 2D array, I think that we've probably got this from assignment 1. So you may even be looking back through your own code rather than my example code for this question if you want to jog your memory for what you want to do. So let's say I give you a piece of code and it has a function in it that says evens. And evens, if we go through the detail, the question might say you're going to get a 2-dimensional array that is square, and it's going to be of this size. And what you're supposed to do is loop through this array and print out on their own line all the even numbers then you see in the array. So you can see that what we're testing here, we're not even testing whether you can create this, because we're saying you're going to get given the array. But what we're testing is, can you loop through an array, and can you look at every element in the array? So all we're saying here is like, can you loop through this grid of numbers, and can you test each number in this grid to see if it means something or not? So that's the level of question that we might ask in question 1, and you can see why I consider this to be fundamental to your capabilities in COMP1511. You can see why I'm saying here, I want to know whether you can loop through an array, right? So that's testing whether you can use variables, whether you can use arrays, whether you can use loops. And that's all like, up to like maybe week 4. So that's saying, okay, can you do this, what I consider to be completely necessary if you want to continue learning about programming. Terry, are you solving it right now? Okay, Terry's giving you a solution in chat to this, and that's fine. And this question might be something you want to practice as well. There's also one in the lab that you can actually do and run with auto tests. Okay, example question 2. Here is a linked list. So please add up all the values stored in this linked list and then return that integer. Oh, Tom says you're going to have a compiler error somewhere. I'm not reading that in detail, so I'm not going to know. Okay, so similar kind of thing, we might give you a function. It won't always be I'll give you a function. Sometimes I'll give you a blank file and expect you to work from that as well. So this is some list where you get given a pointer to the head of a list and you have to add up all the numbers that are in the list. So as you can see here, this is also a reasonably simple question where what we're asking you to do is to loop through a list and look at every element in the list and do something with it. It won't always just be a single list here. I might ask you to like loop through 2 lists in parallel or something like that. But either way, you can see what this is testing you on. This isn't actually testing you on the hard bits of the linked lists. Like, this isn't saying can you insert or remove from a linked list. This is just saying someone else has already made a linked list. Do you understand how to move from one item to the next in the list? So do you understand that the next pointer points at the next item in the list, and then you can write a loop that goes through the list? So can I go through the list, add them together? Which means, can I not just go through the loop through a list? Do I also know the difference between what is in scope and out of scope in a loop? So I'm going to need a variable that's outside the loop to track this total, and then I can add to that total inside the loop, So I'm testing a few of those different things there as well. So you can see I'm testing people's ability to use functions. I'm testing people's ability to use structs. I'm testing whether people can put a variable inside or outside a loop and what the difference is. Those things I consider to be like sort of fundamental to your understanding, but not actually the fully difficult stuff. So it's not like insert into this list in alphabetical order or something. I consider that to be a much more difficult thing to do. Just seeing what people are talking about there. No, that's fine. Okay, so questions 3 and 4 are also hurdle questions, but you don't have to complete them if you've completed the other hurdle questions. So questions 1 and 2 are pretty easy hurdle questions. 3 and 4 are moderate hurdle questions. So it's much easier to spend your time on questions 1 and 2 if you want to. Having said that, I still consider questions 3 and 4 to be basically core knowledge for the course. They're worth 15 marks each. So if you can do questions 1, 2, 3, and 4, you're already on 60 marks for the course, which means you're aiming at a credit depending on how you go in the theory questions. So that's roughly where we are here. So we could even say that parts of 3 and 4 are beyond core knowledge for the course. So when we're looking at these harder hurdles, I might be looping through the array or linked list more than once. So I might do something like, tell me if an array has any duplicates in it. In which case, you look at an element and then you look at all the others, and then you look at another element and look at all the others. So that's like a loop within a loop. There's some double looping going on, so it's more difficult. I might test more difficult conditions. So I might say, not just total all the numbers in here. I might say total all of the numbers in a list that are divisible by one of the other numbers in the list, right? And it's like, oh, that's really complicated and stuff. There's more stuff going on there. There may be insertion and removal going on as well. Question 3 will always be about arrays. Question 4 will always be about linked lists. So if you want to, you could map out what you're expecting to see in all of the questions in the exam based on the information that I'm giving you. I can't remember if I have an example. No, I don't have an example here for that, but there's an example in the lab for that. Because if I start talking about the examples for these, it'll take much longer. Okay, question 5 and 6 are harder C questions. Question 5 will nearly always use strings because you can see how the odd numbers are array questions and the even numbers are linked list questions in the first 6. Question 7 is like no holds barred, everything's open there. But these will be like the third weekly test questions, depending, because they're not always the same. Some week 3 weekly test questions are harder than others. Also, the weekly test questions were based on a 1-hour timeline for 3 questions. These are a little bit longer. So you see how you go. So we might have things like fgets, fputs. We might ask about command line arguments. You can see how these are going to go together with the strings question. Question 6 that has linked lists may have stuff like insertion and removal. I mean, you can kind of count on it because if we're going to escalate the difficulty, then it's going to have stuff like that. You might have to do leak check. You may have to make sure that your thing's freeing memory correctly. It also might use an abstract data type. We won't ask you to build an abstract data type from scratch. We'll probably give you the file structure, but then we'll say, okay, given this file structure and this H file, can you then put these pieces together? So we may do something like that. Having said that, you'll have all the reference material, so you can look things up if you need, but questions 5 and 6 will also have interesting problem-solving things. So because we know a lot about programming, we've all done a lot of programming, those of us who are fiddling with the exam, we may ask you things like, here's a question that appears to be difficult to program when you first see it. And then you're going to have to think really carefully about how to solve that problem before you try doing anything with it. Yeah. And in here is where we might throw in a question that just says this is not being completely tested. See if you can think about how you might use the spec differently to write your own tests. So definitely around question 5 and 6 is where we'll probably notify you. I think we will, actually. I'm just going to make sure. We haven't written all of the questions yet. We have our plan for them. So here is where we might say, this question does not have a complete set of auto tests. You may need to think about what functionality you need to implement beyond what you can see in the tests here. So this is where we get to the more advanced level. We're expecting people to be able to do stuff like that. Just seeing what people are asking about. Yep, no, that's okay. Yuji needs thinking, lol, rip. I'm pretty sure you can think. I'm pretty sure everyone who's in this course so far has done a lot more problem solving than you think you have. Um, Also, you don't even need to answer like those harder questions to pass the course, right? And question 7, I'm gonna say, question 7 is for people who are chasing HDs or trying to get full marks in the course. Note this is only 10 marks. You can get 90 in the course without answering this question at all. I have hired people to teach this course who didn't attempt this question in the final exam, right? So this is where we're at with this one. This is not something that I consider to be core knowledge that you need. This is the question where if people feel like showing off in COMP1511, this is where you go. I do often like to mark this one personally because I like to see who's coming up with interesting ideas and stuff like this. But this is super hard challenge questions. So we will be testing your ability. Hello, lecturer in charge, just going past there. We'll be testing your ability here to see if you can break something down into smaller parts and try to solve some of them. So this one, Maddie's asking if this is a challenge or a compulsory one. I mean, oh, Tom wants to mark this one. It's like you really don't need to do this one, but if you want to do this one, you can. Yes, there are marks for it. Those marks aren't above 100%. They're actually in the 100% this time. So if you want 100% the course, then yeah, you have to do it. I don't expect anyone to need to 100% the course because there is no need. There's no magical separate degree program you go into for 100% in COMP1511. Everyone's still in the same degree. Yeah. So, there's a past. We used to have 8 questions. We dropped it to 7 because we figured 7 and 8 were both just abominably hard, and we didn't need 2 of those questions. But there's a past question 8 in the lab this week, so you can see the difficulty level this might be. Some of you might look at this and say, I think I can figure out a way to solve this. I could get some of the marks for this, and that's fine. Some of you will think of a complete solution to this and it'll be like, okay, go nuts. But you don't have to. So it's super hard. So like the one in the lab this week shows you the rough level difficulty, and I think that the question that we've been talking about, Tom and I have been discussing ideas for this, is probably around that level. So see how you go. Oh, people are asking about marking for the second assignment. Apologies, no. Because of the compression of how tight the timeline is between the second assignment due date and the exam, and there's nothing we can do about that timeline. That's fixed. Because we can't make... If we made this second assignment due earlier, you just have less time to do it, and it would be more painful. And we can't change when the exam is. We can't actually turn around the marking by the time the exam starts. So we can't give you full feedback on the second assignment, unfortunately, before the exam. But hopefully that doesn't significantly change how you'd approach the exam. I mean, if you're totally counting specific marks and stuff like that, then maybe there's an issue there. But you probably know roughly how many marks you're going to get for the assignment based on how much you did and what the auto tests are. Yeah, I would say still aim to do the best you can in the exam regardless of what happened in assignment 2. Yeah, if we had to get the exam ready while we were accelerating the assignment marking, I don't think Tom or I would be entirely human after that. And of course, we are humans now, of course. Okay. So, little bit of thinking about what to study. So, we've obviously aimed your study at certain things because we've said these are the hurdles. So we do want you to study how to use arrays and linked lists. And I say that broad knowledge is better than really, really specific knowledge with gaps. So if you know arrays like super well, and you don't know linked lists at all, then I would say fill that gap if you can. Try to learn a bit more about the linked lists. There's the revision sections on the course webpage. I think there are some revision questions in the tutes and labs if you want to. You can always just go back and look at the tute questions as well, because you may have forgotten some of those, and they do this kind of usually build up of each concept. Oh, I think I've got more detail on this. Yeah. So I've got a series of the things that you are going to need to know about. So the things that are super important. You need to know how to use variables, if statements, looping, functions, arrays and linked lists are obviously in here. I've mentioned them already. There are some things you need to know to be able to use all of these. So you want to know characters and strings because they're linked in with arrays. If you want to be able to use linked lists, you need pointers, structs, and memory allocation. So there's a bit of a dependency here that if I say linked lists are important, that means pointers, structs, and memory allocation are important. There are some stretch goals, though. These things are things that I don't think are super important, that will be useful in your future, but I'm not really going to test them now because I don't think that we've covered them at a level that I think that you can have full understanding of them yet. So if you don't know anything about abstract data types, you can still pass this course. Sure, you're not going to be able to answer every question in the exam, but that's fine. You don't need to answer every question in the exam to pass a course. Multi-file programs are not necessarily going to be tested that deeply in the exam. So as you can see, the stuff that I taught you last is the stuff that I haven't given you a full amount of time to completely understand, so I don't need to examine that for the fundamentals. Obviously, the fundamentals are the things that I've covered in great detail. So the first half of the course is about all the basics like variables, if statements, looping, and arrays and stuff like that. Second half of the course was really very much building up your skills in memory management and your idea to work with the concept of a linked list and how it joins together and stuff like that. Someone was saying that software design development doesn't do linked lists and linked lists are too hard for high school. I don't know, I would potentially agree with that. You know, we used to teach a version of this course to high school students. So there's actually a UNSW course called HS1917 that's delivered to high school students, which is really very similar to this course. By the way, if there's anyone out there right now who is looking at doing computing later and is watching these videos, hello, how's it going? You get to do this for real maybe next year or so, because I know I've been told by our school manager that a lot of people who are thinking about doing computing in the future have actually been watching these lectures. So hi there. I don't think they'll be in the chat though, because these are unlisted and just for people in the course first. But I make all of my lecture material public, so it's all available. People can watch it. So I don't know, Terry, if they're watching it right now. They're probably watching it after I make it public, but there are some people watching it, so that's cool. Okay, so I should talk about the marking. I have not done a great deal of what I expected to do in this lecture because we ended up talking entirely about the exam and things about that. I have a whole section here on recapping programming, which I haven't done, which I apologize, but what I'm going to do is squeeze the recap into the 2 hours next week, on Thursday instead. Okay, because I'm running out of time, let's talk about marking. So, auto tests will help you to make sure your input-output format matches the spec exactly. Make sure you're doing that. That's important. If you don't receive full marks for a hurdle question, or especially if you receive close to the 50% or less than the 50% in the hurdle question, we will mark those by hand. We will go through and we will see if it's a simple mistake that caused the problem and you've shown understanding. So if you show understanding of arrays or linked lists, we'll be giving you the marks for them. But we do want you to be able to show the understanding. So if you can show the understanding but you happen to fail the auto tests or the marking tests, we're still going to be checking it. And as I said before, don't count your auto tests. Check whether your auto tests are letting you know whether you've met specification or not, which is very different from whether you pass all of the auto tests or not. Um, we'll also see if it's a small issue like a typo. Similarly to a lot of people saw this in the assignments, if you have a typo where things have not, where you've lost more marks than you should have for just one little typo or one little issue, we'll correct that and you still get some marks. You're obviously not going to get full marks, because if you've got a typo that makes you fail tests, that means you weren't testing it completely. So we can't give you full marks for not testing something completely. But if it's a simple error and you can show that you understand something, we're still going to be looking at that. Okay, we should have the results back around the 1st of September, so we're talking about 2 weeks after the exam finishes. We should be able to mark it all. We're trying to mark all of the assignments and the exams, and a lot of the people I have to marking are doing exams themselves, so it's always going to be different. Yeah, Leon, there is a revision section. I sent a notice saying that it was going to appear, but I didn't send a link to it because it wasn't up yet. So if you look on the course website, you can find the revision section. There's also, let me just shrink my face so that you can see everything here. There is a supplementary exam, and if there are any needs for special consideration, we will obviously try to help people out. So if you're feeling like you can't do the exam, so if you're feeling like you're too sick to do the exam over 24 hours or anything like that, just don't start it. You don't have to start it. Get a medical certificate if you can, and apply for special consideration, because we have a second exam, which is the supplementary exam that will be held between the 7th and the 11th of September. That's the official UNSW calendar for that. So I think that's during the break before term 3 starts. So if you can't sit the exam and you have special consideration, you can sit the supplementary instead. If you get sick during the exam and it affects how you do it, definitely get in contact with us. So this email address is going to be the way you contact us during the exam anyway. So you're definitely going to want to let us know if anything goes wrong. This goes not just for if you get sick during the exam. If you have a problem with your internet or anything like that, that's also something that you want to contact us about. In general, anything goes wrong with the exam, this is how you contact us. So use this email address if you need to. Okay, I should wrap it up there because we are now a couple of minutes over time, so I'm cutting into the tutorial time. I can't believe I completely missed the second half of the lecture that I've been planning on talking about, which was a recap of the course. So what I'm going to do is super squeeze the recap of the course into the 2 hours on Thursday. We're going to go through everything that we've covered in the course. I'm going to quick fire through all of the topics. So I will wrap it up there, and I'll switch over to the be right back slide. I'm just going to let Chicken say bye, because she's been sitting here most of the time while I've been lecturing. So that's a see you soon from Chicken. So I'm going to switch it to the be right back slide for a bit, and I'll come back and answer questions. But if you've got a tute to go to, you should probably go to the tute. All right, I'm back. Let's just... Hello. Hello, friend. If anyone has any questions, feel free to ask those questions now. And Chicken is here to answer your questions if you need um, about the exam. So Jed's asking if stacks will be in question 7. Maybe. Not necessarily. But question 7 may have such a full-on level of complexity that you might come up with a solution that would use stacks. You might solve it even without stacks, or it might not ask about stacks at all. It might have something completely different. So basically, question 7 is the super open one, which is like anything in the course could come up. Like we could throw in some super curveballs in question 7. Austin's asking if Chicken can bless you with good luck. There you go. You're getting your blessing for good luck there from Chicken. I don't know if she appreciated that. Terry's asking if stacks will come up in questions 1 through to 6. Stacks could come up in question... Hang on a second. Could come up in question 5 or 6. May use an abstract data type. It won't necessarily be stacks at that point. It might just be like, we might actually give you a question like, here's an abstract data type, now implement parts of it, or something like that. Guojin Chen is asking, do I need to do the style test in the exam? You don't necessarily need to do code style for the exam. So we are only going to hand mark things if they need to be hand marked. I would suggest that it should still be readable enough that if someone hand marks it, then they need to be able to read it. But you don't really have to do the super specific really, really nice readable code. We understand that we're putting you under a lot of time pressure, and so you're probably just going to hammer out the code. Terry's saying you didn't know much about stacks. That's fine. I didn't teach you that much about stacks. I taught you a vague concept and showed that there was some implementation, but not that you had to fully understand it. So if you've got a vague idea about the theory of it, you'll probably be fine. Or you just know where you need to look it up. They're not something that I consider to be super important to your programming capability at the moment. They will be super important to your programming capability maybe in a year or two, and then you're going to want full understanding then, but right here and now in 1511, not super important. Yeah. Terry's also asking, is a queue a type of linked list function? I wouldn't say so. I'd say a queue is an abstract idea that whatever goes in earliest is the thing that comes out. And I wouldn't say that it necessarily has anything to do with linked lists at all. Like a queue is not related to linked lists, other than if you want to, you can use linked lists to create queues. That's the only thing that I'd say would be the same. Hugo's saying that you're having trouble saving and checking the text editor. I assume you mean the text file that will be covered in the lab this week. That means that the text file that you're supposed to edit for the multiple choice questions, that's the thing you're having problems with, is it? I think that would be a good thing to test out a few ways that it may or may not work, and bring it into your tutor and talk to your tutor about it, because it might be a specific problem. So it might be something about the way that your setup is working, or the way that the editing's working, or the way that the submission's working, and we can't be 100% sure about what problem it is, so I reckon you're going to want some one-on-one help with that. Charles is asking you about header comments with date and ZID in the exam. No, you don't really need those. You can put them in if you really want them. I mean, if you're just doing it out of instinct and you put them in, I'm not going to say delete them or anything. But we know what date you did it on, and we know who you are because it's a controlled exam environment. So if it comes from you, we know when it happened and we know who did it. So it doesn't really need to be it doesn't really need to be said explicitly in the header comments. So consider these to be, I mean, you could think of these as nearly code fragments rather than fully functional programs that you're going to need to use for stuff. If we have no other questions from anyone, I think we'll wrap it up there. Chicken is being very, very cute today, so she knows that she's not going to see you for very much more, so she wanted to say goodbye. Well, it's not nearly goodbye yet. We still got next week. We've still got next lecture and then a live stream next week, which you might see again. People are enjoying seeing Chicken. Mid morning is a nice time for her. She's just very, very relaxed. You know what I should do is, like, while you're doing the exam, I should just do a live stream where, like, I just pat Chicken to make you feel better about the fact that you have to do an exam. She'd be up for that. Look at that, she loves it. Okay, I should wrap it up there. Thank you all. I will be going through a recap of the entire course. I'm going to do like a super, super fast 2 hour long recap of the entire course on Thursday. We'll see if I can actually do that in 2 hours. And that will be our final official lecture for the course. Okay. See you all soon. See you on Thursday.